Okay, have a quick go at those questions there on the board to get started with. So this is all about moments again. These are already perpendicular, so these are quite quick to work out. This is 200 Newton meters clockwise, and this is 150 Newton meters anti-clockwise. You can just multiply them because they are already perpendicular to each other. If you had to go at the challenge, you were told that things were in equilibrium. Now, equilibrium, what does it mean here? It means that the moments are balanced. Okay? Because nothing's rotating. That's the equilibrium sort of part. You were told that they were equal. So this 240 Newton meters clockwise must be equal to the other one. Well, the other one is 5x anti-clockwise. So you could solve that, okay, and you could conclude that this is 48 newtons. This is sort of where we're going to be going a little bit later. This is about solving problems in equilibrium. So another term we should talk about is resultant. So resultant means the overall. The overall might be clockwise, might be anti-clockwise, might be zero. Zero is a special case. That's called equilibrium. You don't know until you work them out. The first one is the starter. So 200 clockwise, 150 anti-clockwise. Overall, the clockwise will win by 50. So the resultant is 50 Newton meters clockwise. That means the thing is going to rotate clockwise. Let's have a look at this one here. So it looks a little bit different. It looks more like a balance, which we're going to be doing a lot of in a minute. What we need to do here is 1, 2, 3. We need to make sure that with each force, we look at it, we think carefully what the moment is, and then overall what happens. So let's start with number 1. So number 1, if you are to the left and it's up, that is clockwise. So I'm going to put clockwise here, and I'm going to put anti-clockwise here. So number 1 is clockwise. It's 5, it's already perpendicular, and it's 2, 1. It's 3 away. So 3 times 5 is 15. What about force 2? It's to the left and it's down. That's moving it anti-clockwise. This thing that I'm doing of visualizing, you need to do this as well, okay, to make sure you pick the right one. So it's 4, it's 1 away. So it's 1 times 4, which is 4. Done, done. 3. If you are to the right and it's up, you are moving anti-clockwise. So it's 1 times 3, which is 3. So overall, 18 clockwise, 4 anti-clockwise. What's the resultant moment? Those numbers right? We made a mistake. 15 minus 4 minus 3. Oh, I'm sorry, I put this one in the wrong list. We did say anti-clockwise, didn't we? So there you go. You see how easy it is to make a mistake with this sort of thing. So that should be 15, and that should be 7. Yeah, so 8. Clockwise wins by 8, so 8 Newton meters clockwise. Okay. Why don't you pause the video and have a go at the last 2 before I reveal them? So over here, this person is 50 kilograms. Well, moments are not about mass. They are about weight. 50 G. That's what it needs to turn into. This person over here, 30 kilograms, 30 G. It's all about forces. We're only interested in the forces. 50 G, 1 away, so that's anti-clockwise. Anti-clockwise is 50 Newton meters. Clockwise is 30, it's 3 away. Clockwise is 90 Newton meters, so 40 clockwise. This one over here, it's sort of really just helping you get used to the fact that sometimes you might have distance using algebra and unknowns. So if the whole thing is x and this is 4, what are you left with? Well, you had x and you took away 4. So this is called x minus 4. The test is, look, x minus 4, what would x minus 4 need to become x? you would need to add on the 4. So yeah, this is a little trick you can do in your head to check your answer. So there's only one force here. This is 30G, and it's x minus 4 away. So 30G times x minus 4 in Newton meters. And that would be clockwise. Angles, if things are at angles, we just do that trick that we talked about last lesson. Okay, so there are 1, 2, 3 forces here. And if we want a resultant moment, that means the overall moment, we will need clockwise and anti-clockwise. And for the moments themselves, we will need perpendicular distances. So that's what you should turn this into. 2 is ready for you to work out, by the way. Okay, 1 and 3 are just a little bit more difficult. So what's 1 going to do? If you're to the left and it goes that way, that's clockwise. So let's do clockwise, anti-clockwise. So you might remember the shortcut now. The hypotenuse is 1 plus 3, so it's 4. The included angle is use sine, so it's 4 sine 80. That's what the distance will be. This distance here will be 4 sine 80. Have a go for yourself. If you do it as a right angle triangle, you should get 4 sine 80 for that side there. The force is 5, so you multiply it together. Normally we put those together at the front. So we say 20 sine 80. No, you do not need to work out what sine 80 is. It'll be really untidy, okay? Unless it wants significant figures or something, just leave it like that for now. 2 is to the left and down. That's anti-clockwise. So that's 6 times 3. There's nothing else to do on that one. It's 18. You may have spotted kind of a shortcut here about when it's clockwise and when it's anti-clockwise. If so, great. If not, don't worry. We'll talk about that later. The last one, to the right and up, that's anti-clockwise. So that's going to be 3 sine 40 times by 4. So that's going to be the same as 12 sine 40. So what you would do is you will add that up together, okay? And you will sort of compare these, do a subtraction, and you'll find out which one is dominant. In fact, you might be able to. Do we have that slide hidden in here somewhere? Yeah, we do. Let's just have a look to finish it off. So this is one way of doing it. These were the anti-clockwise ones. Yeah. The anti-clockwise ones added together, take away the clockwise. Overall, it says that it's going to be anti-clockwise. Okay. So why don't you pause the video and have a go at your turn, see if you can apply the same kind of idea. The first thing to do, and I will help you out with this, is I'll draw the perpendicular distances on. Look at the 7 Newton force, look at the 4 Newton force, and think about what they're going to do. Is it clockwise, anti-clockwise, and so on. Pause the video and have a go. Okay, so assuming that you've had a go at this, at that one there, this is what we should end up with. So included angle, this is called the included angle. So that's going to be 8 sine 25 times 7. That's it. That's the moment for this force done. The other one here, again, included angle. If I'm saying included angle and that makes no sense to you, by the way, just draw them out again. Okay, for example, just draw this out, this triangle only. Yeah, if you draw this out like this, you will get the correct answer. Yeah, you're trying to find this distance here, and then, only then, when you're done with all of that, do you multiply it by the force. Overall, it's clockwise, okay, 5.3 Newton meters clockwise. So you should now be in a position where you can have a go at 4B.